Hi, everyone. Can you all see the whiteboard?
Yes.
Okay. What answers did you get for the first question? I see a few different answers. 36 is correct. Anish, can you explain?
Um. I solved it by assuming that the first balloon would cost $1. So then the second balloon would cost 66 cents. So the two balloons combined would be $1.66. And then for $30, yes, for wait, you have to do 30 times 1.66. So you get, 30 divided by 1.66. So you get 8, around 17.9. And then if you multiply that by 2, you get 36.
Good. Yep. So the idea is essentially you can look at, so kind of maybe the tricky portion here is that you get this, when you buy the first balloon at regular price, you get the second at 1/3 off the regular price. So then it doesn't continue in that, so that's a pair. So then the next one you have to buy again at regular price, and then the fourth is a discount, and so on. So one way of doing it is, as Anish said, you can assume that one balloon costs $1. Second balloon then will be 1/3 off, and then you can compute. So originally you had $30 to buy 30 balloons and divide by 1.66. So this is now 1.66 is for 2 balloons. So you can multiply that back by 2 to get the number of balloons. And alternatively, what you can do is, so if you know before it cost you whatever 2 units to buy 2 balloons, or whatever the price is, let's say X was the cost of 1 balloon. So we don't have to assume it's $1. So 2X is the cost of 2 balloons initially. Now, with this discount, the first one costs X, the second one costs 2X over 3. So after this discount, it's 5X over 3 is the cost of 2 balloons. And if we can, to avoid the fractions, we can multiply these by 3. So then 6X is the cost of 6 balloons. And if we multiply the other one by 6, we get 5X is the cost of 6 balloons. So essentially, we're getting what we had to pay to, for 6 balloons, we had to pay 6X. Now we have to only pay 5X. So let's say we originally had 30X. So 30X was the cost of 30 balloons. Now if we multiply this by 6, then we see 30X is now the cost of 36 balloons. So this, without assuming what the cost of one balloon is, we can kind of do this arithmetic, assuming this is the cost of this many balloons, and just multiply by, if I buy this many more balloons, I just multiply the cost by that factor. So I can see initially 30X was the cost of 30 balloons. With this discount, 30X becomes the cost of 36 balloons. So you can buy 36 balloons instead of 30 balloons, given this sale. Does this make sense? Any questions? Okay, let's go to the second question. Okay, good. 7 out of 72 is correct. Sanvi, can you explain?
Okay, what was it called?
Go ahead, Sanvi.
Okay, so for if you wanted all 4 of the dice to share the same value, the first number you roll doesn't matter.
Mhm.
So that's a 1 times, and now for the second roll, you have to get a 1/6 or a certain number. And so that certain number is 1/6, the probability, times 1/6 again, same thing for the third one, and fourth, which is also 1/6. So this becomes 1 out of 2/16. And therefore, if you want 3 out of the 4 dice to show the same value, there are 4 possible outcomes where 3 out of 4 of them are show the same value. So it becomes 4 times 1, because just like before, the value of the first dice doesn't really matter. And since there's 4 outcomes, it becomes 4 times 1 times 1/6 for the second dice. It has to be a certain number. 1/6 for the third dice has to be a certain number too. And for the third dice, it has to be, it's a 5/6 chance, because the first dice, it already counts as whatever number you're hoping for, and then 1/6 is that same number again, and the other 1/6 is that same number again, and then the 5/6, they can't be that X you're wanting, so it has to be a 5/6. And if you multiply this, you get 5 out of 54. And if you add 1 and 2/16 plus 5 out of 54, you get 7 out of 72.
Good. Yep. So this is one good approach. So you can compute in terms of probabilities. There's 2 cases. So you have 4 dice, and you want at least 3 of the 4 to show the same value. So one possibility is all of them are the same value, and that's the easier case. Or exactly 3 of them have the same value, and the other one has to have a different value. So the first case, you can just think about the probabilities. The first one, you can roll anything. The second one has to be the same as the first, so the probability is 1/6. Third has to be the same as the first, probability is 1/6. Fourth has to be the same as the first, probability is 1/6. So that case is easy. There's a 1/216 chance that all the dice are the same. They could be all ones, all twos, all threes, whatever, up to all sixes, because we took the probability of 1 of rolling anything on the first die. Now for 3 out of 4 being the same, the only kind of difference is this extra multiplier here. And the reason for this is because when we have our 4 dice, we could have let's say A is one of the values and B is the other, it could be A, B. So my first three rolls are the same value if the fourth one is the different value, or it could be B, A, it could be A, B, A, it could be A, B, A. So the kind of the different roll that I have from the other three, it could be in any of the four positions. So that's 4 choose 1 or just 4. So I have to have this extra multiplier of 4. And then I can assume it was just one of these cases, because then I'm just multiplying by 4 to account for all of these. So once I take out the multiplier of 4, then I can assume it happened like this. So I had 3 rolls of the same value, and my last roll was a different value. So if that's the case, then the first one I can roll anything. And whatever I roll, that becomes A. So once I roll that, the second one needs to be the same value as the first. So there's a 1/6 probability of that. The third one has to be the same as the first again. There's a 1/6 probability of that. And the last one has to be something different from A. If it's the same as A, then it becomes the first case of all dice being the same. So we have to take, it has to be one of the other 5 possibilities. So that's probability 5/6. So you can multiply this out, you'll see it's 20 over 216. Then you can just add up the probabilities of the two cases. So 20 over 216 for 3 out of 4 being the same, 1 out of 216 for all of the dice being the same. Adding that up gives 7 over 72. So there's one more way of doing this that's similar, but you can do it just in terms of counting outcomes rather than looking at probabilities. So what is the total number of outcomes of four dice rolls? So how many outcomes are there for one roll of the dice?
There is 6 outcomes for one roll, so in all 4 rolls there'll be 24 total outcomes.
Close. So good. 6 outcomes is correct for one die. But when I roll it twice, right, I could have 1, 1, 1, 2, 1, 3, and so on, right? Then I could have 2, 1, 2, 2, and so on. So I have 6 choices for the first die and then 6 for the second, right? So it becomes 6 times 6 is for 2 dice. So what about if I do 4 dice?
It's 1, 2, 9, 6 possible outcomes.
Good. So that's actually 6 to the power 4. So let's not expand that just yet. But yeah. So 6 to the power 4. Now we can count of those outcomes, how many satisfy this criteria. So that, which means the 4 rolls have to be either in the form AAAA or what we saw before, AAAB, or the B being somewhere else, AABA, and so on. So either all 4 being the same, or again, 3 out of 4 being the same. So how many outcomes have all 4 being the same? So either all 4 can be 1s, all 4 can be 2s, all 4 can be 3s.
6 possible ways for all of them.
Yep. And now in this case, again, we have to think about, we could have this in the form AAAB, AABA, ABAA, or BAAA. So let's just pick one of these first. If I have the roll being AAAB, how many outcomes are there here? Possible. So there's 6 choices for the A. It could be any of 1, 2, 3, 4, 5, 6. And then 5 choices for the B, right?
Mm-hmm.
So this is 30 outcomes. And that's the same for each of the other ones. So I can just multiply by 4 for the 4 ways of choosing the one die that's different, or just count 30 for each of these. So what's the total number of outcomes that satisfy with 3 of the 4 dice, at least 3 of the 4 dice showing the same result?
126.
Good, 126. over 6 to the 4th power. So 126 outcomes work, and we know there's a total of 6 times 6 times 6 times 6 outcomes total. So the nice thing by not expanding this is now we can cancel a 6 from the numerator and denominator. So that gives us 21 over 6 times 6 times 6. Now, is there anything else we can cancel here?
If you break the 6 up to into a 3 and a 2, you can do 21 divided by 3, which is 7.
Good. Yep. So we can cancel a 3 again from numerator and denominator. So we're left with 7 by 72. So the same answer in both cases. Essentially, they're doing the same thing. In one case, we're just taking the total number of outcomes of 4 dice, 6 choices for each die, and then counting the number of outcomes where at least 3 of the 4 values are the same. So this is a little bit easier. You don't have to think about it in terms of probabilities when you consider each case. You just think about, when I have 4 dice, what are the outcomes that can happen, which satisfy, and then compute the probability at the end. Or you can take the 2 cases, compute a probability for each one, and then add up these probabilities. But in a sense, they're counting the same thing in different ways here. Does this make sense? Any questions on this? Okay, let's move on to the last question. Okay, 35 is correct. Sanvi, can you explain?
Okay, so what I did was I first put a 9 in the 6th place because it says it's the median.
Mhm.
And if you want the largest number you can get, you want the left side of the 9 to have the lowest possible value, so you can put more for the largest integer. So 1 is the smallest positive number.
Mhm.
And so what I did was I put I put 1 and I put an 8 next to the 9 because it has a unique mode of 8. So I put 2 8s.
Mhm.
And so then I put a 2 next to, and okay, I accidentally did something wrong on the left side, but I put a 1, a 2, and an 8, and an 8, which doesn't work because 8 is supposed to be the mode.
Mhm.
But well, so what I did was even though that side's not right, I took 1 plus 1 plus 2 plus 8 plus 8, which is 20, and I added the 9 to it, which is 29.
Mhm.
And so if 8 is supposed to be the mode, then you can't repeat anything on the right side of the 9. So it would be 10, 11, 12, and 13. And so if you add all that up,
Mhm.
you get 75.
Mhm.
And 110, which is supposed to be the total value. If there's 11 integers and an average of 10, you do 110 minus 75, you get 35.
Okay, good. Yep, you're on the right track. So let's actually double check. I think there's a small change that we have to make here, but so let's look at this. So okay, so we started off with 9 being in the middle. We know that. So let's go back through the constraints we're given here. So we have a median of 9. So that means that in the list, when I sort them in order, the 6th number is 9. We have a mean of 10. So this tells us the sum of all the numbers is 11 times 10, or 110. And now we have a unique mode of 8. So what this means is 8 is the most common number, and there's no other number that appears the same number of times. So this doesn't necessarily mean it only appears 2 times. And I think that's a key point here that will matter. But for right now, let's imagine, let's say it did appear only 2 times. So we know that 9 is the middle number, 8 appeared 2 times. So if 8 is the unique mode, that means that no other number can appear twice. So every other number has to be distinct. So what that means is I want the smallest possible numbers here, as Sanvi said. So we'll try to start from 1. We can't have another 1, so we have to put a 2. We can't have another 2, we have to put a 3 here. Now on the right-hand side, also we want to put as small numbers as possible so that we get the largest possible value at the end. So this also we can pick 10, 11, 12, 13, because we know they have to be above 9. 9 is the middle number. And we don't want to make them higher than needed to make this number as large as possible. So now let's see what the sum is here. So 1 plus 2 plus 3 plus 8 plus 8 plus 9, 10, 11, 12, 13. So what is the sum here? Any ideas?
Can you repeat what you were asking, please?
Huh?
Can you repeat the question?
Oh, yeah, just what is the sum? 1 plus 2 plus 3 plus 8 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13.
It's 77.
Good. So what does that mean the last number should be?
33. That's what I got first, but then it changed it and I got 35.
Okay, so 35 is the correct answer, but let's see why. So in this case, these are the numbers, we'll only get 33. And let me double check. Yep, okay. So yeah, in this case, we can only get 33. Let's think about, so what was the one assumption that we made to reach this point? So we knew the middle number had to be 9. That was true. We said 8 appeared only 2 times, right? We were just told it was a unique mode. That means it could have appeared more than 2 times. And initially, it'll seem that that's wouldn't really help us because we want the smallest numbers on the left side. Why would we want to include 8 more than 2 times? And let's see what that might change. Let me make, again, 11 spots for the 11 numbers. Okay. Now we know, again, the middle number had to be 9. Now let's say instead of 2 8s, we actually had 3 8s. What can the first two numbers be now? The smallest possible numbers they can be.
1 and 1.
Good. So the nice thing now is we can actually make this also a 1. Now, what about the second number here?
It could be 10, 10, and 11, 11.
Could we do anything better than 10 here for the second value? For this next value?
You could do 9,
Good.
then 10, 10,
Mhm.
then 11, and the last number.
Yes. Okay. So now, what would be our last element in this case? So now we know that the sum again is 110. Let's sum these numbers.
$75,
Good. So what would be the last number here?
$35.
Good. So this is the correct approach. You have to take the 11 slots, think about, okay, the middle number is constrained by 9. How do we minimize the left side? But intuitively, you feel like, oh, let's only put 8 2 times because we can put smaller numbers here. But actually, in this case, you're benefited by putting 3 8s, and then you can duplicate the smaller numbers. You can put 2 1s here, 2 9s, 2 10s, and on 11, rather than having to put 10, 11, 12, 13, 1, 2, 3, and you can actually put a larger number at the end because of that. And you could even try putting 4 8s, but in this case, that won't really help you much more because you could put 4 8s here, just 1 1 here, and then 3 9s, 2 10s, and you wouldn't be able to get actually better than this 35. But technically, you should think about all these cases. Just seeing unique mode of 8 doesn't necessarily mean it appears 2 times. And actually, in this case, having it appear 3 times lets you have a larger final value in this list. Does this make sense?
Yes.
Any questions? Okay, then that's it for today's class. We'll see you all next week.
Thank you.
Thank you.
Welcome.